Hi student, in this video I will show you how to find limit using factorization. For the case when we have a rational function and then we substitute limit or we substitute the value, we get in the form of 0 over 0. For example, we have limit x approaches to 2, x square minus 4 divided by x minus 2. Okay, when we substitute x equal to 2 at numerator, we get 0 and denominator also 0. So we get in the form of 0 over 0. So 0 over 0 is not equal to 0 or this is not the final answer. So what we need to do? We need to factorize numerator. So equal to limit x approaches to 2 x minus 2 times x plus 2 over x minus 2. Okay, for x square minus 4 actually it based on a square minus b square. So when we factorize, equal to a minus b times a plus b. So that's why we get x minus 2 times x plus 2. Okay, here we can cancel out x minus 2. So we get new function, limit x approaches to 2, x plus 2. And then last step, just substitute x equal to 2. So we get 2 plus 2 equal to 4. Okay, next, second example. We have limit x approaches to 3, 3 minus x over x square minus x minus 6. Okay, for this example, when we substitute x equal to 3, at numerator we get 0, denominator also 0. So next step, we proceed with factorization. So we can factorize function at denominator. So we have x times x equal to x square, 6, 3 times 2 equal to 6. So we get 3x and 2x. We want negative x. So negative 3x or negative 3 and negative 6. So when factorize this, we get actually x plus 2 times x minus 3, or you can use your calculator to factorization. So equal to limit x approaches to 3, 3 minus x over x plus 2 times x minus 3. And then we need to cancel out term. But for this case, we can't cancel out x minus 3 with 3 minus x because have the different sign. So what we can do, at numerator, we can factor out negative. We get limit x approaches to 3, negative. So we get negative 3 plus x. Negative 3 plus x actually equal to x minus 3 over x plus 2 times x minus 3. So we can cancel out this term. So we get new function, limit x approaches to 3, negative 1 over x plus 2. Okay, last step, just substitute x equal to 3. So we get negative 1 over 3 plus 2, or final answer equal to negative 1 over 5. Okay, next we move to example number 3. So we have limit x approaches to 4 for x minus 16 over x square minus 4x plus 2x plus 1. Okay, for this question, we have the first function here is rational function and the second function here is polynomial or as a linear. So when we substitute x equal to 4 for the rational function, actually we got 0 over 0. Since we get 0 over 0, what we can do here, we need to separate the term or separate the limit. So equal to limit x approaches to 4 for x minus 16 over x square minus 4x plus limit x approaches to 4 to x plus 1. So for the first limit, since we get 0 over 0, what we can do, we need to factorize. So limit x approaches to 4, factorize numerator, we can factor out 4 times x minus 4 over, and then denominator we can factor out x times x minus 4. So here we can cancel out x minus 4. So we got new limit or new function 4 over x, and then last step substitute 4 over 4 equal to 1. This is the final answer. Sorry, this is not the final answer since we have another function plus with limit x approaches to 4 to x plus 1. So just substitute, we get 2 times 4 plus 1 plus with x plus 1 plus 9, and then 1 plus 9 equal to 10. 10 is the final answer. Okay, next example number 4. We have limit x approaches to 3, 9 over x minus 3 over x minus 3. Okay, for this question, when we substitute x equal to 3, we also get 0 over 0. What we can do, we need to factorize. But before we factorize, we need to simplify this fraction first, because we want our fraction in form of a over b. Okay, what you can do, we can multiply 3 with x. So limit x approaches to 3, 9 minus 3x over x minus 3 over 1. So our fraction here actually in form of a over b divided by c over d. Okay, now we want to write in the form of a over b. So equal to limit x approaches to 3, 9 minus 3x over x times with 1 over x minus 3. So we get limit x approaches to 3, 9 minus 3x over x times x minus 3. Okay, next we want to factorize. So limit x approaches to 3, we can factorize numerator. We can factor out 3. 3 times 3 minus x over x times x minus 3. So from here we can cancel out x minus 3. Since the sign for the function at numerator is not same, so what you can do, we can factor out negative sign at numerator. We get negative 3. So x minus 3 over x times x minus 3. And then we can cancel out x minus 3. So we get new function negative 3 over x. And then last step, just substitute x equal to 3. So the final answer equal to negative 1. Okay, next example number 5. if we have limit x approaches to 0, e power of 2x minus e power of x over e power of 2x minus 1. So here we have exponential function. When we substitute x equal to 0 into this fraction, we also get 0 over 0. Before that, let's me explain about exponential function. If we have x times x, we have power 1, we get equal to, we have the same base x. So just plus the power, we get x squared. But if we have e power of x times e power of x equal to, we have the same base e, and then we plus the power, x plus x equal to 2x. E power of 2x actually equal to x squared. So first we can factorize numerator and denominator. So equal to limit x approaches to 0, e power of, we can factorize e power of x times e power of x minus 1 divide by, okay, denominator e power of 2x minus 1, actually equivalent to x squared minus 1. X squared minus 1, we can use theorem a squared minus b squared. So x squared minus 1 actually equal to x minus 1 times x plus 1. But for exponent e power of 2x minus 1, we can get e power of x minus 1 times e power of x plus 1. So here we can cancel out e power of x minus 1. So we get new function e power of x over e power of x plus 1. And then last step, just substitute x equal to 0. So we get e power of 0 over e power of 0 plus 1. E power of 0 equal to 1. So 1 over 1 plus 1. The final answer equal to 1 over 2. Okay, thank you.